Okay, next topic is histogram and frequency distribution. We've done something similar to that in previous chapters. That was slide statistics. Number 4, collecting, organizing, and displaying data. So this was histogram, pie chart, tally. Remember that?
Yes.
So now this would go in a bit more detail. Histogram and frequency distribution. So we are going to look at histograms, continuous class intervals. We may have different class intervals which will lead us to frequency density. We have frequency, we have group tables, raw data or group tables, and frequency tables. Model class is the mod, most frequent, cumulative frequency curve, quartiles. We'll be having upper quartile, median quartile, and lower quartile, and then interquartile range is upper quartile minus lower quartile, and then percentiles. Pure statistics. Recap, we had some numbers for x and frequency. So f into x, and total of that mean is sum of numbers over number of numbers. Most frequent value in this case is 1, as the frequency, highest frequency is 12, opposite to 1. And median, if I have total 26, this is 26 plus 1 by 2, and this is 27 by 2, 13.5. So these are 12 numbers, and when I enter in the second level, I covered 13.5, so my median is 2. Mid of 13 and 14th value.
So with the 12 and
Sure, go
5,
on.
and then median should be 2?
Median should be 2. So if I arrange these numbers in order, first 12 numbers are going to be 1. That means the 12th number is 1, 13th number is 2, and 14th is also 2. Because
That
we
way it
got
makes it the
13.5
median.
as the mid number.
Yeah.
Yes.
Okay.
So that's why it is 2. And using the same data to draw frequency histogram, or just an example 130 to 40. Yeah, different example. So this is the histogram. We have the frequency, we have values on x. So 132, that's class from 130 to 40, and the frequency is 40. 140 to 50, frequency is 30, and so on. Another histogram, just displaying the data. A worked example, the table and the histogram below show the height of the tree in a sample from a forestry site. So classes are 0 to 5, 5 to 10, 10 to 15, and so on. The first thing to notice is that all the classes are of equal width. If they would be of different width, we will not draw frequency, but frequency density. We'll look at it later. So classes are equal, so the width of all the bars are equal. We have the frequencies, one of the frequencies 0, and see there's no bar in 30 to 35. So how many trees are less than 5 meter tall? So how many are less than 5 meter tall? Are 21 only.
21.
What is the most common height of the tree? So maximum frequency is 30. So most common height is 25 to 30. How many trees are 20 meter or taller?
So we just have to add, yep. Do we also add the one before, like the 15 to 20, or?
No, that will be actually less than 20.
Okay.
So we are looking at 20 or taller. D-Bart says, why do you think the class interval includes inequality symbols? Definitely because, yeah, go on.
Because it can either be that number or above, like higher than that number, because it needs to end at a certain point.
That is one answer. Yes. The other is like we do not have the exact data. Like when we use less than, it may be that number or less than that number. There's no actual data and the data is continuous, like in decimals.
So because we don't know it, like we show it less than or equal to.
Yes.
Okay.
Why is there a gap between the columns on the right hand side of the graph?
Because there's no value. Like
There's
there's
no
no
value.
data
There's
in
no
the
tree
area.
between 30 and 35. The height is 0. Sorry, there are 0 trees with height 30 to 35. That's why there's a gap. Joy Ann did an experiment in her class to see what mass of resins in grams the students could hold in one hand. These are her results. Using the class interval of 16 to 20, 21 to 25, 26 to 30, and before we draw, I can just see the gap from 20 to 21. Now that's a gap. 25 to 26, that's a gap. Like if there is a value 25.5, where would we place it? Which is definitely not in this case. There is no value in decimals. But when we draw, that would be either a bar chart, and if he asks us to draw the histogram, he's asking for histogram. So we'll have to eliminate that gap. So first of all, 16 to 20. 1, 2, 3. So we have 3 values and so on. So 21 to 25. We keep counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 values. 26 to 30. 1, 2, 3, 4, 5, 5 values. 31 to 35. 1, 2. When we fill in that table. What is the model class? The mod, which is 21 to 25. Last says draw the histogram. Now we know histogram has no gaps. So when I see at the mass of grains, the classes, I see that there's a gap of 1 in all of these. So I have to eliminate that. I'm going to use the midpoints. So if I use the midpoint, this will be 20.5 and the next one starts from 20.5 and the next ends at 25.5. That brings us 16.5 lower, that is 15.5. So 25.5, 30.5.
Those are just the midpoints, right? Between
Yes,
like the intervals. Okay.
yes, and the last one is raised by 0.5 just to eliminate the gap. And we will be using these symbols less than, equal to, and less than. If we write these tables, or else we just draw these values. See, 15.5 to 20.5, and then 20.5 to 25.5, and there's no gap. Draw the histogram, that was the last part. And these symbols, less than, equal to, and less than. Because actually the lesser value is included in that class and the upper value actually goes in the next group. See, this was 20. So if there is any value more than 20, that goes in the next group. Exercise. Maria is a midwife who recorded the mass of the babies she delivered in 1 month. What is the model class? Which one is it?
2.5 to 3.5.
2.5 less than, equal to, m is less than 3.5. How many babies have a mass of 2.5 kg or less?
13.
Very good. Draw the histogram to show. So is there gap already?
There is no
Yes,
gaps.
there is no gap. Are the classes equal?
The classes are equal.
So we just straight away draw X and Y and complete it. So I'm just taking this as 0.5 and ending at 1.5. 1, 2, 3, 4, 5. I'm taking 2, 1, 2. This is third, this is fourth, this is fifth interval. So first one, the height is 1. Next, the height is 12. This would definitely be more accurate on graph paper. And then 31. I should have kept that a little lower for now. So this would be 31 and so on. 16 and last is 0. That's a straight line. NK did a breakdown of the length of telephone calls on her mobile phone account. These are her results. The length of time 0, 2, 4, 6, 8, 10, 12, 14, 16. With no gaps and all equal, simple histogram. Frequency is given. How many calls did she make altogether? I'm getting 142. Are you getting the same numbers?
We just have to add all the frequencies, right?
Yes.
And I'm getting, yep, 142.
What is the most common length of the call?
It's 2 to 4 minutes.
2 to 4 minutes. 2 less than equal to t is less than 4. Draw a histogram to show the distribution. So same thing goes over. This is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 classes. And then again, frequency on the y-axis, and we draw that. Make a new frequency table of these results using the class intervals given in the following table. Okay, that would be easy. 0 to 4. 0 to 4. May I just add these two? 43 and 15. 0 to 4, there are 58 calls. And then 4 to 8. 12 and 19 is 31. 8 to 12 is 25. And 28. Write a few sentences comparing the distribution shown on the two histograms. If we would just draw these two, that would be very easy to compare. But if you just think he's added all these, but if he just adds them again, 58 and 31, 58 and 31 would be 89. I'm just trying to make you understand that when we make less columns, this is 53. And if we add them again, 89 plus 53, that is if he makes only one block of 142. So that would be 0 to 16 and block of 142. Whereas if we have distribution like these four, one is 58, the other is 31, then I have 25, then I have 28. You see the block on right and left?
Yes, one has more diversity, one is more
Diversity.
accurate.
More accurate, yes. So when he's reducing the number of intervals or the interval is large enough, we are actually losing the actual data.
So that's why the histogram is better, like the bar graph.
Histogram or bar graph would be same, but having more classes. See this on the right. If I just add all of them, that is 142. So I'll be writing 142 here, and from 0 to 16 minutes, there were total for 142 classes calls.
Yes.
This would be only one block. And what is it giving me? No idea, nothing. And if I just quickly go through this, let's say this is 15, this is 43, whereas from 0 to 4, I just got a height of 43 and 15, in total 58. So there were 58 calls which were from 0 to 4 minutes. But if I compare it with this, I would know that 43 were from 2 to 4 and 0 to 2 were 12. More accurate data.
The first one is better because of that, because it's showing more data.
And more even analysis. Shamila cut 30 pieces of ribbon, which she estimated were each about 30 centimeter long. Our sister measured them and got the following actual lengths in centimeters. Draw a suitable frequency distribution table for this data. Now we'll have to look closely and decide what the classes should be. This is 29.1, 30.2, 31. So I'm looking at what is the least possible value. 29.1 till now and 28.8. 28.8 is the least value. And the highest is 32.1. 32.1. I can see is 32.4. Now we have to decide the interval. If I just say 28 to 29, 29 to 30, 30 to 31, 28 less than equal to x is less than 29, then 29 to 30, 30 to 31, 31 to 32, and 32 to 33. So I have 1, 2, 3, 4, 5 classes. Draw a suitable frequency table. So this is x, and then we count and write those frequencies and construct a histogram to show your distribution, and then we draw. How accurately did Shmela estimate? Give a reason for your answer. Let me display the answers as well. This is chapter 20, exercise 20.1. Question 3. And the answer to last one also. The smaller the class interval, the more detailed information is represented. The larger class interval gives good general picture of the data. And question 3, not very accurate. Only 11 out of 30 were within 0.5 centimeters of 30.
But it was still in that range. Like,
See this first thing. Shimela cut 30 pieces of ribbon, which he estimated were about 30 centimeters.
yes.
About 30. So they made a count that only 11 out of 30 were within this range.
Oh, it
If
has
she's,
to be in the 0.5 centimeters
yeah,
range.
if
Okay.
if if there's a client, they would actually expect that every length of ribbon should be 30. They cut it with accuracy. So out of those total 30, this data is actually, these are 30 numbers. So 11 is actually zero point 0.5 near that value, like 30.5 or 29.5. And other values are more than that or less than that. So that 2 is almost 36% within that range.
Oh, so it's like too little to be considered accurate.
Yes. If you just ask me to cut pieces of paper, which should be 7 centimeter each. So if I just cut them and they're 7 or 7.1 or 6.9, you would just accept it. But if it is like 7.9 and 8 and 9, so that will not be acceptable because the desired length was 7. So if you just see the table on the right, I'm starting with 28. That is 2 centimeters from 30. Even we made this statement on our own that 30.5, if it is 30 centimeters, one would not accept 31. One would not accept 29. They asked for 30. So if it is 30 point something or few points less than 30, or we round off the data and it should become 30, would be acceptable.
Okay.
The French traffic police recorded the number of vehicles speeding on a stretch of highway on a Friday night. Draw a histogram to show this data. Okay, now there's only one thing which we have to do is adjust the classes. So this gap of 1 only, that's 10 becomes 10.5. This is 20.5, 30.5, 40.5. The upper part is now 50.5 and the lower part is 0.5. So the classes would be 0.5 to 10.5, 10, 20, 30, 40, 50.5. And heights are already given. Classes are of equal width. So we just straight away mark the x and draw all those bars. 47, 21, 32, 7, and 4. Here are the IQ test scores of a group of students. IQ test scores are given, frequency is given, 95 and 99. I'm just looking at the left hand side, 500, 5, 10, 15. So there's a change of 5, 5 all. Then 99 plus 5 is 4, plus 5 is 9, 4, 9, 4, 9, 4, 9, 4. And the last should have ended at 139. Draw a histogram to show the distribution. So all the gap of 0.5, 0.5 again. So we just disappear that gap and draw the frequencies just like we did in question number 4. This was question 4 and this is question 5. We just disappear the gap and draw the given data. Now this is something which needs to be done carefully. Histogram with unequal class intervals. Have you done frequency density before?
I've not heard of it, but possibly.
Okay. Now let's consider some data. This is X, this is F. Let's say all the classes are like 0 to 5. And then I have 5 to 15. And then 15 to 20. And then 20 to 25. Are these classes equal?
Yes.
Now look at the second
Oh,
one.
wait. First one is only 5, and then second. Oh. No, it's not equal. It's uneven.
Yes. Now what I'm going to do is draw one histogram with this given data, and then with the frequency density to show that frequency density is the correct way to display them. So if we just have these classes starting from 0, 5, 10, 15, 20, and 25. The first value is 4. The second is 8 from 5 to 15, and which should be of double height as 4 appears. Then 12 should be this height. And 20 to 25 is 4 again. Now we are going to do frequency density. Frequency density is frequency divided by class width. I'm writing class width for myself on this same table. Class width is 5, this is 10, this is 5, this is 5. And frequency density is frequency divided by class width. 4 divided by 5 is 0.8. 8 by 10 is 0.8. 12 by 5 is 2.4. And 4 by 5 is 0.8. You see the classes are of equal distribution again, 5, 10, 15, 20, 25. And on left hand side I'm marking this as 0.8, then 1.6, then 2.4. So see, the first one is 0.8.
Yes.
Notice that the second one is 0.8 again, but from 5 to 15. Notice the third one is 2.4 from 5 to 20. And the third one is 0.5 again, 0.8 again from 20 to 25. Now see the difference between these. Before we make any discussion, how many people were there from 0 to 5?
4.
4. And from 20 to 25?
4.
4. So first and last class are equal number of people, and if I make the comparison of these two boxes, this is equal area, right?
Yes.
And what happens when we compare this 4 and 8? Number of people are actually double, and when you look at the area, what happens?
It doubles as well.
It is 4 times.
Oh, because one of those little boxes would fit 4 times instead of the bigger
Yep.
one.
Yes. Now see, if I would just compare this on right hand side where we do frequency density, this is frequency density. Now compare anything with anyone. First two, 4 and 8. Do you see double area? The frequency doubles, the area doubles.
Yes.
And compare the first one with the third one. Do you see the first and third 3 times the area?
Yes.
And then again first with last. So frequency density gives you a good impression, the correct impression. If you are showing frequency against classes to someone, they would just assume that from 0 to 5 there are, if there are x, then 5 to 15 there are 4x. But in reality they are only double, not 4 times. And if you would just compare this 12 with this 8, in reality the 12 is more frequency, but this graph shows that this area is actually lesser than 5 to 15. So this is why when the intervals are not equal, we prefer frequency density. Getting it?
So just the addition of like the frequency divided by the like distance between them. So we choose to do like the histographs because they like give us more idea of what the area and or the distance between the values are, or like how much there is.
Yes.
Okay.
And understanding this table, that we can use frequency density to find frequency, that is simple, multiplying these two. See, frequency density is on y-axis and class width is on x-axis. So what is actually happening when we multiply these two? We get the area of the box. So we never actually write this thing, but we know that frequency is equals to area of the bar or histogram or box. Because examiner may ask you that how many people are there from 6 to 17. So I would just know that 6 starts from this point and 17 is somewhere in this point. So I'm just going to find the area from 6 to 15. I know this is 9 and the height is 0.8, plus from 15 to 17 is 2 and the height is 2.4. Getting it?
So
What
it's
is
how
this?
many people are there. We have to find the area.
Yeah, frequency. I'm just saying it again. It might be number of goals. It might be number of votes or people or objects, anything. But more important is that it is frequency of something.
So to find the frequency, we need to find the area of it. Frequency is area.
Yes.
So the examiner might ask us how many people are there from 6 to 17, right? But it can be any value, and that would just mean finding the area of it. Okay.
Like sometimes there are technical words which we should exactly write in exam and which we would be reading in questions. But there are few terms which we can communicate with each other for better understanding. So frequency is always equal to area of the graph, which is also proved by frequency density into class width gives you the frequency, which is x-axis and y-axis of the same given data.
Will they ever ask us like why is frequency the area, and then we'll have to do like the formula?
They would actually never ask, but if they do, your answer is correct.
Okay.
Exercise: 140 people at a school fundraising event were asked to guess how many sweets were. Okay. Here is a suitable table showing the height of 50 plants. Okay, that was just an example. I thought the question is missing. Here is a table showing the height of 25 plants. Draw a histogram to show these results. So if they're asking about histogram, already no gap, but first one, the width is 10. Second width is 5, 5, and 15. So I've written class width. Now I need frequency density. And what was frequency density? Frequency density is frequency divided by class width. So 4 divided by 10.
0.4.
0.4. 8 by 5.
0.16. I mean 1.6.
1.6. And 7 by 5.
1.4.
0.4. 6 by 15 is 0.4. Oh, it's already done as well. So now we have frequency density. We will plot frequency density on y-axis and those normal class widths on x-axis, and this is what we get compared to this, which would have been the result of frequency only. You see, I can now see that from 5 to 15, whatever the number is actually 2/3 of this number. But this representation is something else. Or just compare first and second. So that does not give the correct representation. Any confusion till now?
No.
Okay, in a large glass jar, this is 490, 489, 480. I think this line belongs to the question on the next page. 140 people at school fundraising event were asked to guess the number of sweets were in the glass jar. So I'm writing that number here. 140 people were asked. So those who guessed correctly were put into the draw to win the sweets as prize. The table shows the guesses. Number of sweets. 18 people guessed that they were 100 to 200. 18 said 200 to 250. 32 said 250 to 300, and so on. Use the table to calculate the frequency density for the classes. So class width, frequency density. 100, 50, 50, 50, 50, and 100. So frequency divided by class width 0.18. This is 0.36. 32 by 50 is 0.64. 31 by 50 is 0.62. 21 by 50 is 0.42. And the last one, 20 by 100, is 0.2. Use the table to calculate ton. Construct the histogram to display the results. Use a scale of 1 centimeter 100 on horizontal axis. So 1 centimeter 100. So it starts from 100. This is 200, then 300, and so on. And scale of 1 to represent 0.2 on vertical axis. 0.2, 0.4, 0.6, and so on. So this is question number 1 of 20.2, 20.2. And this is how the graph would look like. One centimeter on x-axis, and yes, I missed that thing. Do you see this jack line?
Yes.
Because the graph is not starting from 0, so we can just write this.
So we don't have to put like a long distance from 0.
Exactly. I just did this. It's got stuck. Let me re-input it. This was a mistake, starting it from 100. Jack, 100, 200, 300, and so on. Every next question would be similar to the previous one. Apart from those questions we did in examples, that how many were more than 8, less than 4, how many are within the given range, etc., etc. Let's try this with the given bars.
A, right?
Question 6.
Yes, A.
Yes.
I'm going to say it's easy because we just have to find the area of the cube to find how many people did travel above or below the speed limit.
Yes. Is it easy to see how many vehicles traveled above or below the speed limit? Give a reason for your answer. So if 125 is the speed limit, I can just mark on 125, this is 100, 120, 130, 125. So yes, these were vehicles which were actually more than that. Is it easy to see? So I would say yes, because the area of their last box is giving the number of vehicles.
So it's easy because we can easily like find the area of it easily, which is the frequency. Area is the frequency.
Area is the frequency, yes. Let's see if he thinks the same way. No, frequency density are not okay. Got the point. So why are we saying no? Because it is not straight away readable. We have to calculate it.
Oh, so anything we have to calculate for is not going to be easy?
Yes. Right. As compared to this is also frequency. As compared to this one on the left, this
Yeah.
is 5 to 10 is straight away giving me that there were 4. 15 to 20 is straight away giving me that there were 8. So in this case, we choose no because we will have to calculate it. I just thought that calculation is not hard. But yes, in this case, we will say no, it is not easy because we have to make those calculations. As this is giving me 10, so number of vehicles are not actually 10. So more than 125 to 180, 125 and 180, the difference is 55. 55 into 10 is 550 vehicles. D part. The traffic officer claims the graph shows that most people stick to the speed limit Is he correct? Give a reason for your answer. So if we just look at this, I think this time that should be a yes because maximum area is less than 125.
So that's why a lot of people follow the speed limit.
Yes, they're not overspeeding. One can see most of the bars within boundary and speed limits, yes. His colleagues want to know exactly how many vehicles travel below or above the speed limit. To reconstruct the frequency table, so we will use this and fill this up. Can you do that? Is it readable?
It's readable.
on it?
Yes.
That was so silent, I thought you left. Still doing?
Yes, but I'm almost done. Okay, I'm done.
Let me check. Okay, that was class width. I wrote the class itself. So are you getting these values?
I'm gonna check frequency first and
Should I speak?
sorry?
Should I dictate?
No, it's okay. Yes. Okay. Okay.
Okay. How many vehicles were below minimum speed limit? So minimum or maximum? Maximum speed limit is 125 and the minimum is 50. Okay. So how many were below 50? The first frequency. So there were 240 which were below speed limit. What percent of vehicle in the sample were exceeding the maximum speed limit? So maximum speed limit is 125 and there were 638 which were exceeding 638 divided by all of these into 100.
638 divided by
So 638 plus 19 plus 960 plus 780 plus 500 plus 320 plus 240 and we're getting 4257. 4257. 638 divided by 4257 times 100 and I'm getting 14.987 which is 15%. 15% were overspeeding, 240 were below speed limit. Let me do this with you. The unfinished histogram and the table give information about the height in centimeters of the senior students at the school. Frequency densities are given. So some of the data is given in the Histogram sum in the table. Use the histogram to complete the table. Use the table to complete the histogram. So if I just look at the second, that is 150 to 160. The height is 35. So 35 into 10 is 350. No, 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 no. See, 140 to 150, the frequency density is 15, his writing frequency is 15. So basically, he's taking 140 to 150 as 1 unit. So 150 to 160 will be 1 unit, and this is 35.
So he's taking the frequency as itself as just one part? Why?
We can actually do that sometimes. If, like, for example, I was getting all these values 0.8, 0.8, 2.4, 0.8. If I just choose to convert it into 8, 8, 24, and 8, that will also give me exact ratios because I've increased all the numbers by 10 times 10. So this is going to give me the exact representation because 0.8 is a very small number, and if you want to avoid decimals, so we can do that. We can represent it that way. So this graph actually gives you that 140 to 150, where when I said that the area is the frequency, so this should have been 150. This should have been 150, but he wrote 15. So we're getting that they are considering 10 on horizontal axis as one standard unit. So this is again standard unit. We just copy that 170 to 180 is standard unit. So we just copy that, and this in this case is 22. From 170 to 180 is 22. I'll come to the other values as well. So 190 to 210, if you see, this is one standard unit, these are two standard units. So the height is 6. 6, 6 into 2, 12 is the frequency. Getting it?
Because it's 2 units,
Yes.
it would make it double the height
Yes.
of it.
Yes.
Okay.
Because we take 10 as 1 unit, so 20 as 2 units. So this is basically 20 into 6, 2 into 6, 12. Now see this in green bar from 65 to 170.
So
The
it'd be
height
half.
36, sure, very good. So half of that will be 18. Now see 160 to 65. Or let's do 180 to 190 first. These are 12. That is one standard difference, that is 10. So we just draw it 12. Then look at this 20, 60 to 65 is missing. The height is 20. So I'm drawing it at 10. One standard unit 20, 20, 40. This should be at 40. This should be at 40. This is question 7. Height should be 40. Yeah, 40. Because I have to represent 20 frequency. One standard difference and 20 should be 20. But when the width is half, the height goes double to show the same frequency.
Okay.
I'll share these first 10 pages to just have a brief overview. Practice any question you wish. All of them are actually the same. And I'll share practice test also. And I was actually unable to do it today. I had electricity shortage for around 36 hours.
Okay. Could you also send like some questions on trigonometry?
In place of frequency.
So it's not the midpoint, but it's just the upper bound subtracted by the lower bound.
Yes.
Okay. And that gives us the class width. Okay.
Yes. Starting and ending point difference between them. Now, if you could compare these two, the one on the left is basically frequency against height. One on right is frequency density. Now, also have a look at the data. If you look at the first frequency, that is 4. The second is 8, which completely shows us that there are double number of people or double number of plants in the second group. But when you look at the areas, see what happens. From 5 to 15, this is the block, and from 15 to 20, it should have been double, but the area is looking exactly the same in left hand side. One rectangle and second rectangle. This should have been doubled.
So
Whereas when
frequency data is made to use it more, like to make it more accurate.
more accurate, it shows displays the same area and the correct and same representation of the data.
Okay.
Again, compare it with this 6. See the ones at with 8 and 7.
Yes.
This is 8 and this is 7. If someone just looks at the frequency height, they would consider that there are maximum number of people from 25 to 40. But that is not the case. They were just 6. And when you look at the frequency density, that gives you a clear picture. You can see that this area is actually lesser than this one,
But the
which is
15 for the class width, isn't that showing just how much people there is, like just how much data that was
no,
collected?
class width is actually the length only and how many plants were in that width. Like from 15 to 20, there were 8 plants who had their heights between 15 and 20. There were 8 plants who had their heights between 15 and 20. There were 6 plants who had their height between 25 and 40.
Okay. And then the class width is just
Yeah. If I just
how.
do not draw bits and I just label them A and B, and I say this is A and this is B, any doubt which one is more?
No, A is more.
A is more. Now, in these two, one could be doubt.
Oh, that's so the frequency density just blocks that doubt. But the
Yes.
class width, it's still just the
Well, I'll give you an example. For example, we are doing a survey on roadside on a highway, and you have a speedometer with you, and you see how many cars are passing through 0 to 10 with speed of 0 to 10, then 10 to 20, then 20 to 30. But during the survey, during the exercise, you would realize that this is a highway and none of the car would be passing at least with a minimum speed of 60. Getting from 30 to 40, then to 50, then to 60, because you will be getting zeros for all these. None of the car passed across with the speed of 50, 60. And then you found a car that there were 3 cars from 60 to 70. So maybe you would like to consider to make one of the class as 0 to 60 and the other at 60 to 70, then 70 to 80, or maybe 90. So you see, we're getting unequal classes. So the class width actually has nothing to do with the originally collected data. But that was only one thing, that maybe we are getting very less values in few classes, so we combine them. And then to adjust that change, we draw frequency density.
So class width has nothing to do with the data collected.
Yes. Like for example, you are just collecting the data and you know exact speed of cars. So if I just ask you make classes of 5 class width, so you may do 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, because you have actual data. So you could just uh, make a new table. But if I ask you make widths of 0 to 20, 20 to 40, 40 to 60, so new data could be done. But because I didn't do the survey, you did it. You may advise that there were very less cars from 0 to 60. You may advise that we can make only 2 blocks, 0 to 30 and 30 to 60. This is the only purpose of making different class widths. For example, we are at school and we are conducting a survey in the senior classes, and that is age versus number of people. So when I ask 0 to 5 years of age, do you think there would be anyone?
No, nobody.
5 to 10,
Nobody.
10 to 15,
Yes.
maybe. So we are getting a number, maybe. Now 15 to 20,
Yes, definitely.
so maybe. And in my mind, I have a perception that there are like 16 years of age till the final class.
Yep.
And then 20 to 25, maybe zero again.
Yeah.
And moving on, if we are also asking the teachers, maybe the first person is 30 something or between 30, 35 something. So this is one of the way all the classes are of equal width. So I would just be wasting the space. And if we just consider, depending on our data, that let's do it from 0 to 15, the first class. So we don't have zeros, we don't have gaps in our histogram. And then from 15 onwards, 15 to 20 is again a zero. If I would just consider this in red, and 20 to 25, 15 to 20 is 1, 15 to 25 is 0, and 30 to 35 is 1. If I will draw this histogram, first 0 to 15 is giving me 3, then 15 to 20 is giving me 1, and then the last 20 to 25 is giving me 0. So that's a gap, that's a break. And this, so maybe I want to break this gap. Now if I do this, like I combine these three, then I combine these two, and the last one.
So class width prevents from breaks happening in a histogram, basically.
Yes. So we may have this one. No, no. The first one is 3 times. The second one is actually double, and the third one is this much width. So this is 3 height, then 1 height, and 1 height. But this again is not the actual representation, because we knew this was 0, this was 0, this alone was 3. So then we do frequency divided by class width to get the correct area of the bar, because area would incorporate both height and width. That
Frequency,
takes into height and width both. Frequency is the height.
frequency, yeah, frequency divided by class width gives us the frequency
Yes,
density.
That's true. Another example I would like to show that, which we discussed last time. Now, this is the same data from 0 to 5, 5 to 15, 15, 20, 20, 25. So you see those two in yellow, 4 and 8. So when we just draw frequency against that class, against classes, this first one yellow is 0 to 5, then second 5 to 15. The table says that it is actually double of that, but the graph says it is 4 times because the area shown in the graph is actually 4 times. Now compare it with the frequency density on right hand side, first block and second block.
It shows that it's double.
Yeah. So it is the required adjustment.
Okay, so finding frequency from frequency density would just be frequency frequency density times the class width, right?
Very good. Yes. This formula. So we just
Yeah.
multiply these two, or we
And
can
then
call it area of the bar.
finding class width would just be frequency times frequency density.
Finding class width from this given data, yes, that would be frequency divided by frequency density because you're making class width the subject now. If you make class width the subject of formula, this is your new rearranging.
Okay.
But
What
we,
about sample size?
yeah, that would also be considered. Just let me clear this. You will never get a question like this. You will have to find class width from this given data. This is your class width. Okay, now sample size is basically a theoretical question that would never be against a numerical, which actually tells you that will you consider making decisions on this data? So that is sample size. One of the example which we just considered, age of students. So we might consider that as true because in senior school, in every school, students would be around this age. Like from grade 1 to 5, average age would be same. 5 to 10, average age would be same. So performing experiment on one school would be enough to make decisions. But like if we are talking about sports, let's say, so conducting experiment in one school wouldn't be enough to make decisions for the entire city. So that is sample space. We would say sample space is less.
So finding, for example, if a question asks us how many students were tested, but beforehand they didn't give us like any value of how many students were tested, but there's there's the histogram and with the frequency
Yes.
density and then the height in centimeters. So we would
That's a very
find so we would find the amount of students by dividing the frequency density by the height.
if we are finding the number of students, we would find by frequency density multiplied with class width. See,
With class width.
frequency density is equals to frequency divided by class width. When we are working on number of people, or number of anything, that is basically frequency. Number is frequency. So we'll just multiply these two and get frequency. The other way is this is my class width, this is my frequency density. So when I multiply these two, I'm actually getting area of the bar. So complete area would give me complete number of people. So what was the sample size? That is equal to total frequency or equal to total area.
Okay.
If you just look at the graph on left, because that is frequency, so the height says there are 4 people. Then the height says there are 8, 7, and 6. So when you just add them, 8, 7 is 15, and 10, 25. So the sample size 25. On right hand side, the width is for the first one, width is 10 into height is 0.4 plus 5 into 1.6 plus 5 into 1.4 plus 15 into 0.4, and we get 25 again. So this is the sample size.
Okay.
Have you ever got into discussion whenever the school makes a date sheet for you, date sheet for examinations? Sometimes the teacher
Um,
may ask you that maybe have two exams a day. Have you ever gone through two exams per day or
yeah,
class
I have.
test?
Yeah, I have.
Sometimes they do ask, and we usually say, I'm talking entirely based on my own experience. We usually say that do not put math and chemistry in one group. Sometimes they have a greater syllabus. So let's say I would say mathematics with English or mathematics with Urdu. So one subject is lengthy and one is easy. So could be managed. Now this again is would be a sample size. The date sheet being set, asking students from one class would not be done for the entire city because they do have different teachers. One school may be comfortable with mathematics and physics, the other school may be comfortable with biology, computers, and arts because they have different teachers. Their experience is different. Those are
So
just
different
relative.
teachers. Yeah. So different teachers would mean that the school was more comfortable with doing the exam because the other teacher would be free.
No, like if you are given the authority to make a date sheet, that would definitely suit your class fellows because you are having same teachers and you would more or less be having same strength and weaknesses in the subject. And if we talk
Oh.
about another school at the other end of the city, maybe their computer teacher is really good and they're confident and they don't care if you put that uh, computers with mathematics or physics. So they have a different experience. The variables are actually different. Maybe your school has a very good lab and you're confident in practicals, and you would just say that we don't need to prepare, we are ready, you may take the exam whenever you wish. So in such cases we do need large sample sizes.
We need large sample sizes to accommodate for all the students doing the test, basically.
Yes.
Okay.
Like for example, if we're taking for a complete city, it would be wise that I would say minimum of 40% of schools should be involved. If there are 1000, we should get data from for 400 schools.
Okay.
Okay, we practiced till this point. Next topic would be cumulative frequency.
I had some questions from like the PDF as well,
Sure, sure.
just individuals. I just wrote them on a paper. So
Yeah,
the
sure.
first one is on page 4. Oh no, page 8, and it's apply your skills A.
Do I need to like open something?
Yeah, it's on the same PDF. It's on the same PDF. It's just I think you scroll back.
Okay. If you have page number at the bottom.
Yeah. I just wrote it by what number on the PDF you sent it to me, but I can quickly check what page it is in like the actual book. Um, it's page 490.
490. 9. Okay. This is 490. And question number is
490 is applied skills A. So that would just be, yeah, applied skills is on the bottom of the page. And then 4A. So that
okay.
would, yeah.
A group of duty soldiers underwent fitness test in which their percentage fat was calculated. The fitness assessor drew up the histogram of the results. How many soldiers were tested? So number of personals, straight away, this is not frequency density. So this time I can just add up the heights directly because it is giving me number directly. So I see this is 3 in the first one. Then we have 20, 20, 20. So 3 plus 20 into 3. Again, the next is 10. Then I have 5. And then I have 1 2 times.
Okay.
So almost
And then for page 491, so the
plus
next
5
page.
plus. I'm getting 75. Let me just quickly recheck.
Okay.
Yeah, there was 110. I just did 5 2 times. So this is 80. And next page.
And then that's just finding, yeah, frequency and frequency density. So we just clear that up as well. Okay, never mind. There's no other questions.
Oh, okay. Okay, I'll just reach out this same question to link it with cumulative frequency and then come back to the original page. Okay, let's use this one. If I would just ask how many students took less than 2 minutes, what would you say? How
15.
many students made calls less than 2 minutes? So that's 15. When I would say less than 4 minutes, what would you say?
So that would just be 43 plus 15. So
That's right.
58.
Now, how many less than 6?
That would be 70.
70. So you see what's going on? We just keep on adding the frequencies. And now I'm adding 15, then 10, and then 11, and then 17. Now, if someone would just ask me that how many were there less than 14, so I would say 125. How many were less than 10? I would say 104. How many were there in total? There were 142. This is cumulative frequency. I've just added them, cumulated them. If you have a
So
question in
cumulative
your,
frequency, sorry?
yeah, sure, go on.
So cumulative frequency is just used to show how many there was before a number, before
Yes,
a certain point. Okay.
yes. If you just prepare a very difficult test in your class, the purpose is to get variable marks. If the test is easy, maybe most of the class would score more than 80%. So now you've prepared a very tough test and you got variable marks. One of the student still scored full. One of the students scored 1 out of 25. And now you're asking your class how many of you got less than 2. Maybe there's one hand. Then you would say how many of you scored less than 5. The person who actually scored 1 would raise his hand again because that's less than 5. Then you say less than 10, less than 20, less than 22. ultimately less than 25, every one of them would have raised their hand. So you'll just keep on collecting data. That is cumulative frequency. It won't increase the total, and you just keep adding every point. Compared to if you are asking someone how many scored 0 to 5, there would be few hands. Then 5 to 10, again different hands. 15 to 10, different hands. So we've been doing
So
classes. Now we are going to do total of all, that is cumulative frequency.
can you find cumulative frequency on like a histogram?
Yes, we can do that because the height of histogram is giving me the number. We just did a question on 490. Yeah, this one. You see from 4 to 8, 4 to 8, there are 3. Then let's say 4, 8 to 12, there are 20. 8 to 12, there are 20. So against cumulative frequency, then again 20, 20, 10, 5, 1, 1. So what would be my cumulative frequency? 23, 43, 63, 73, 78, 79, and 80. So if I would just ask percentage of body fat, how many were there less than 12%? So you would say 23. How many of them were less than 20% body fat? So you would say 63.
Okay, so it is possible.
So cumulative frequency. Sometimes you may be asked questions such as how many people. The best example may be if you are looking at a marathon race and there are like 65 people participating, and from the start time, when everyone starts running, you count that time. Then you see one person passed in this much time, second, third, fourth, fifth. You have every person's individual time. If someone would ask you, at what time did 7 people pass? That would be cumulative. How many people passed till time 12? You'll just add all of them. Maybe someone passed at 8 minutes, but they're asking how many have already passed in 12 minutes. So you'll give the total answer. Sometimes they are like using this data to see how many of them qualify. Every one of them completed the race, but some did it in 8 minutes and some did in 16 minutes. So you would just say those who completed the race in 10 minutes qualified for the next round, and we lay off the others. So how many people had a mass of less than 50 kilogram? How many cars were traveling above 100 kilometer per hour? How many students scored less than 50% on the test? So that is a total. They scored less than 50. Maybe some would have scored less than 10, but they're just asking less than 50. So we make a total of that.
So instead of groups, it's just the total of what
Yes.
the ones before it are. Okay.
Yes. You may also say that doing so, we lose the actual data because histogram was giving us individual separate data. We exactly knew how many people had a body fat from 8 to 12 and so on. If I would just say that one of the data is that there were 9 cars traveling at more than 100 hours, 100 kilometer per hour, more than 100 kilometer per hour. There were 9 cars. So you would never be able to say that were they at 120 or 140 or 150. If I
So
would
it's
just say,
good to yeah, it's good to just add cumulative frequency to your original data, let's say like table, but it's not good to rely on it.
yeah, that would just depend on what type of data are we working on. What do we need to do? what decisions we need to make. So cumulative frequency is simplified form where we do not need very much data in depth. So that's fine.
Would a table be the best way to show data? Because you can
We
show cumulative frequency, you can show the frequency, you can show frequency density, and so class width.
yes, like this one.
Yep.
Scores score out of 10, 3, 4, 5, 6, 7, 8, 9, 10. So there were 4 people who scored 3. There were 5 people who scored 4, 3 again who scored 5, and so on. Now, what does cumulative frequency say? If I would just ask how many people scored 3, there were only 4 people. I would say how many of them scored less than 4. So there were 9. How many of them scored less than 5? There were 12. So if I would just ask how many scored less than 8 and someone is answering 27 people scored either 8 or less. Now 8 or less are 27 people. So I don't know. Actually, maybe 26 scored only 3 and one of them scored 8. So actual data is lost. If someone asks about this data, so they'll get it. 27 students scored 8 or less. But they would never know if there was one genius who scored 8 and the other 26 they're scoring 1 each. They would never know this. So in order to get more detail, they will need this table.
Okay.
And if let's say someone just comes in and says those who scored more than 7 qualify. So I know less than 7 are 20, total are 30, so 10 students just qualified. So cumulative frequency is more of this use. If this was not marks, these were time. So lesser time, these people qualified and these were laid off.
So it just helps us find the total mark, and it can also help in like finding who passed and who didn't.
Yeah, the cutoff bar, the cutoff marks, cutoff time, just without going into details.
Okay.
Like let's say there was a sports event and you conducted it. That was a race, and me without asking every detail, I'm just saying you that those who completed the race in 4 minutes they qualified. So you have the actual data. You will just let the players know who qualified and who didn't.
Okay.
Worked example. The height of plants were measured during an experiment. The results are summarized in the table below. 0, 5, 10, 15, 25, 50. And there's one good thing. You'll have all the classes of equal width for cumulative frequency. So there are 20, 40, 60, 80, 50, and total are 250. So cumulative frequency 20, 20 plus 40, 40 plus 60, and 120 plus 80, 200 plus 50. So this is your cumulative frequency. If I would just say how many plants were there which were less than 50, so that's obviously the total because I'm talking about the highest value. Draw up the cumulative frequency table done. Determine which of the class interval contains the median. Now see what the total height. There are 250, 250 plants. So middle would be 125. Can you hear me?
Yes, I can.
Okay, middle is 125. Now I'm just looking where 125 would fall. That is exactly this block. So my median is 80. So sorry. Median is 15 to 25.
So we find the middle of the cumulative frequency and then that gives us the
Yes, these are 215 total. If I would just line them up, first 20 are 0 to 5. So I'm just lining them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm just lining them up. Then 40 are from 5 to 10. From 5 to 10. So I'll just line up these 40 from 5 to 10. I'll just line up these. Getting the point. So what would
yes.
be the median? Median would be, which is at the middle. That's 125. So I know these are 20, these are 60, these are 120. So 125th would lie in this, and this is my median class.
Oh, I see. So whatever 125 lies on is what the median class is.
Yes. We
Okay.
always arrange it in order, and these tables are always in order. So straight
Okay.
away, median is 125th member or number. So because cumulative frequency has already done the part, and I can just see 125 would lie in this, not in 120, it is more than 120. So it would just lie in this, and that is 15 to 25.
Okay, I see.
Cumulative frequency curves. Now we are going to have these classes on x-axis and cumulative frequency on y-axis, and this would look like this: 0, 5, 10, 15, 25, 50. And we are going to use these upper values only. In case of median, we used midpoint. Now we are going to use these upper values only. So at 5 it is 20, at 10 it is 60, at 15 it is 120, 25 it is 200, and then 250. So I get this cumulative frequency curve. Worked example. Examination marks of 300 students summarized in the table. Draw a cumulative frequency table. I'm using the same and writing cumulative frequency here. These are set 3, then 10. Plus 13 gives me 23.
23.
29 is 52. Plus 44 plus 65 plus 70 plus 49 plus 14 plus 6. There were 300 students. I missed a number. Let me quickly check it. 3 plus 7 is 10. 10 plus 13. 23 plus 29 is 52 plus 44. 96 plus 65 is 161. I missed 65. 161. And this is one more thing. If we don't get the total same, definitely I missed a number or mistyped it. 231 plus 49 plus 14 and 300. So got cumulative frequency. Second part says construct the cumulative frequency graph to show this data. So marks are on x-axis, cumulative frequency is on y-axis. See these marks on x-axis and cumulative frequency 0 to 300 on y-axis.
So
Cumulative
a
frequency on
so a
x.
graph with cumulative frequency would just be a line graph.
Just be a line graph using the upper end values only. This point 3 is plotted against 10. This point 96 is plotted against 50. This point 100 is against 300.
Okay.
And calculate the estimate of the median mark. That is very easy from the graph. These are total 300, and median would be just the midpoint, which is 150. You use the graph and you go there and you get the exact median mark wherever it intersects.
Without the graph, we would just see where it would lie, right?
Yes.
Okay.
Whereas if we would have done it from this table, we would not get the median mark, but we will get the median group, median class. In this case, 300 divided by 2 is 150, and 150 definitely lies in this, which is 51 to 60. So that is non-exact answer, 51 to 60. But from the curve, you get the exact value. And we always give answer from the curve.
Okay.
When we'll move further, the examiner would add up these points as well. This is 50% point. This is 25% point. This is 75% point. You call this median. We will call this lower quartile and upper quartile and call medium sometimes median quartile. And they are also numbered as Q1, Q2, and Q3,
Is there
which
a
is
way
up.
of finding, like, for example, upper quartile from middle quartile without the graph?
No,
No?
because the
Okay.
graph may be steeper, may be less steeper.
Okay.
They do not have any correlation between them. So just in this case, lower quartile is 25%. So 25% of 300 is 75. So I would go on y-axis at 75, draw a horizontal line where it touches the x-axis, come to the x-axis and find the value. Same goes for the upper quartile. Okay, what does this say? The cumulative frequency curve shows the journey of times to school of different students. Some countries have this rule. You are not allowed to take admission in any school, but it should be in the specified distance from your home. Are you aware of that? Such as
I
France.
wasn't. Oh, I wasn't aware of that.
Yeah, they have this rule. Like if you live in this block of city and this is another block of city, this is your home, this is that school, and you like this school, you cannot go to that school because it is far away from your home. What would you do if you want to study there? You would shift here and then you can take admission.
Oh, okay.
There's a system how they control the traffic, the pollution, and everything. And they do provide facilities in every block. Like you won't
Okay.
have to travel from your block into this block for a park all the way, creating pollution. Petrol car, they will provide a park in your block.
So if another better school is another block, you just have to change where you live.
Yes,
Okay.
that is how France works.
Okay.
And I don't think that is the case in Canada or in Pakistan. You could take admission anywhere. You just have to
Yeah.
travel there. And
Yeah.
this very graph shows this, that you can see that some students take 10 minutes to reach school and others might take 100 minutes to reach school. 10 times more. The cumulative frequency curve shows the journey times of schools of different students. We use the curve to find the total number of students. So just have a look. What do you think? How many students are there?
Well, if one person takes 100 minutes,
No, total number of students. The question is how many number of students are there in the survey?
so that would be 60.
This is 60. And if I draw a graph till 70, would you say that the students are 70?
Yes, because isn't the last value the total?
And then I again change 80, what would you say? And 90, what would you say? Because the red line is not changing.
Oh, so where the red line ends, so that would be 50.
Yes. So number of students are 50. In the survey, total number of students are 50.
Yes.
So whenever you get a graph like this, total number is against the value where this graph ends. So there are total 50 students who are surveyed. Number of total students 50. An estimate of median journey time. Median. So there were 15 total. Middle would be 25.
But
So you
isn't
go
that
at
for journey time?
yeah, sure.
No, but isn't that for journey time, not for students?
Now it is for students. Journey time is the answer to the question.
So through the students, we
What
find
was the
the
median
journey
time?
time.
Like you are standing at the door at the gate of the school and you see one student just came, then second, third, fourth, fifth, sixth, and you record that when was it when the 25 student, that means the half of students are here. That is the median
Oh,
time.
okay. So that
So
would
it
be
gives me, yeah, sure, go on.
that'd be around like 38.
Yes, that's 38. Can you just see those blue lines and boxes?
Yep.
Yeah, so that's 38. C part says the number of students who took less than 10 minutes to go to school. Now the question is around time. So less than 10 minutes, 4 students. If the same question would have said more than 10 minutes, we would answer 46. Getting it?
Yes.
So less than 10 minutes were 4. The number of students who had journey times greater than 30 minutes. Either greater than 30 minutes.
32 because we're
30.
finding it 32, right?
Yes, that's correct. 32. The number of students who took between 40 and 1 hour to get to school. Between 40 and 1 hour.
$70? No, it can't be. So
See, between 40 and 60, we just read at 40 first. What do you see on y-axis?
I see it's 28.
Okay. And
And then
what
for
is
the
it?
60, I see 42.
42.
So would I subtract them?
Yes.
That is 14.
14 students. Another example, 20 bean seeds were planted for biology experiment. The heights of the plants were measured after 3 weeks and recorded as below. Find an estimate for the mean height. This is just the mean. Can you do that?
Yes.
While you do, just speak out first. Two
So
steps, maybe.
I just add the frequencies together, and then I divide it by the total number of. So I just divide it by 4.
No,
Height. That would be 3. So it'd just be 3 plus 6 plus 9 plus 12.
no. That would be mid of these two. 1.5 into 2 plus
Oh,
mid of these two. 4.5 into 5 plus 7.5 into 10 plus 10.5 into 3 and divided by total.
so divided by 4. Oh, divided by the total frequency.
Uh, Mean was sum of fx over sum of f.
Fx is the midpoint times the frequency, and
Yes.
f is just the total frequency. Okay. Okay.
Yeah. So what does the B part says? Draw a cumulative frequency curve and find the estimate of median height.
So that would just be with 3, 6, 9, and 12. And we just continue adding the 2, 5, 10, and 3.
Yeah, we use this. This is very good. And cumulative frequency would be, let's just make it here. This is 2, then 2, 5 is 7, and then 17, and 17 and 3 is 20. So 3 against 2, 6 against 7, 9 against 17, and 20. So this is our cumulative frequency curve. And now we need to find the median. We just come at the midpoint, which is 10, and read it from the graph. And the median is 7. Cumulative frequency curve needs to be practiced by hand on graph paper rather than
Okay.
soft copies, because that's what
Okay.
you face in the actual exam. Now the question says
Okay.
the
And
height of
also for like linear equation questions that we did like last topic, those as well, right?
last topic, which one?
Linear equations, quadratic. No, no,
Yeah.
it wasn't last topic, but those ones also have to be practiced on a graph as well.
The ones with graphs, yes.
Okay.
Other than that, for the quadratics, we definitely have different ways: completing square, quadratic formula, midterm breaking.
The ones that say use a graph, then we'd have to practice with it. Okay.
Yes. Yes. Now, as it says, the height of 25 plants, one thing is 25. That is just the total. Says 25 plants were measured to the nearest centimeter. The results are summarized in the table. Draw the cumulative frequency table. So cumulative frequency is 3. 3 plus 7 is 10. 10 plus 10 is 20. 20 plus 5 is 25. This last number would also ensure if it matches that I did it correct. In which interval does the median plant lie? Draw cumulative frequency for this distribution. He's not asking me about the curve. So I have 25 in total. My mid value would be 13. See, these are 25. 13th value, 12 on this side, 12 on this side. Is this my mid value?
12 on the other side and 12 on the other side. 13 can't be the middle value. Are you saying there's 13 middle value for 25?
Yeah, 13 is the mid value for 25.
Doesn't 13 plus 13 equal to 26? Sorry.
Okay, just look at your hand. You have 5 fingers. May I
Yes.
say third one is the middle?
Yes.
1, 3, 4, 5 fingers, and third one is the middle. So what happens when someone has 4 numbers? Middle is second and third. So whatever our value will be on the second place and third place, will take average of that for median. If
So
I'm
that's what the
talking about,
25 is.
yeah, so let's discuss even numbers. If I have 6 numbers, which two are the middle numbers?
It's going to be 2 and 3.
For 6, it is going to
Oh,
be
no, no,
3.
3 and 4.
Okay, let's try one more. 10 in total.
It's gonna be 5 and 6.
Correct. 20 in total.
It's gonna be 15 and 6. Sorry. It's gonna be 10 and 11.
Correct. You see, in even numbers, we're getting two options. But in odd numbers, we'll get only one option. So
Yeah.
there are three in total. Which number is the middle one? Three in total. Middle number
So
would be
the second one
five in total. Middle number would be
would be third.
seven in total. Middle would be
It would be the fourth.
that's right. This is what I just did. For 25 numbers, have 13th as middle number.
Okay.
I'm not thinking too much. I'm just doing 25 by 2 is 12.5, which just tells me it is a mid of 12 and 13.
Okay.
If I say 51, so when I do 51 by 2, I'm getting 25.5, which is telling me it is mid of 25th and 26th number.
51 by 2, and then is this to find which group is the middle point? Median?
Sorry. 51 by 2 is 25.5. So that is the 26th number.
That has to be the median. Okay.
Yes. No, that is the middle number. We have to work out the median. Like suppose I would say there are 25 total students, so 13th student is the middle student. But how much time did he take? What was his height? That is actually the answer. This is X, this is F. Answer is always X, not the frequency. So looking at the frequency, there's one more formula for this, n plus 1 by 2. And I'm just going to put all these numbers again. When I asked you about 10, so that was 10 plus 1 by 2. You already answered that the mid would be 5 and 6. So this is giving me 5.5. 5.5 is due to 5 and 6. And the one at the top, 25 plus 1 by 2, directly gives you 13. So it gives you the middle number. Now this is 13th number. So this is 3. This is 10 in total. And 13 would be covered here. So this is my median class. In which interval would median lie? Median lies in 21 to 25. Because if I would just rearrange all these 6 to 15, there are first three, which are 6 to 15. Then there are 7, 1, 2, 3, 4, 5, 6, 7, which are actually 16 to 20. So median is still not there. Median is in the next class because we have to reach the 13th point.
So it's just gonna be total plus 1 over 2, which would give us our median.
Yes.
Okay, so n equals to total.
Yes. Okay. Third part says draw the cumulative frequency curve and use it to estimate the nearest centimeter, the median plant height. These would obviously be different from table because that is 21 to 25, and from the curve we would get exact value. Number two, I'm just looking if you have different values. Use the information in table above to find the value of P, Q, and R in the following commodity. Yeah, that's a good one. The table shows the amount of money X spent on books by group of students. Classes are given, number of students are given. Calculate the estimate of mean amount of money per student spent on the book. Let's do this. I'm doing it on my end, and then we'll compare the answer. Okay.
Okay.
Are you getting this answer?
Not yet. I'm still trying to figure it.
Okay.
I'm not getting the same answer.
Are you using the midpoints?
Yes.
Into 0, 15 into 4,
Yes.
25 into 8,
Yes.
35 into 12,
Yes.
45 11,
Yes.
55.
Oh, I don't think I added the extra 5. I only did 4 plus 8 plus 12 plus 11. I'm just gonna add that 5 as well.
Okay.
Okay, yeah. Uh, Actually, I'm getting 36.5.
36.5.
Yeah.
Make sure your calculator is not fixed on one decimal place. See what do you get when you punch 2 by 3.
Okay. I just got 6.
Yeah, your calculator is fixed. You should get 0.6, 0.6, 0.6. Maybe you could
Okay.
try like clearing the mode, just reset the calculator.
Okay. I just have to ask my brother to do that. I'm just gonna try with my computer if I can do it there. Okay.
Just tell me the name of your calculator. Which one is it?
Where do I find the name? Oh
Like
no,
just look.
it's Casio.
Yes.
Casio.
Okay. Model number, if you may have.
Um
Or any, just leave. I'll show you. Can you see CLR written over the button 9 above it? CLR, clear.
over the button now? Yeah, I can.
Okay, press this shift at top left corner, then press 9.
Okay.
Now you have
Both at the
three
same
options.
time, right? Like hold
Yeah,
shift and then okay.
down. Shift and then 9.
Okay.
You got these options, press 3.
And
Select
then
the
I
third
press
option and then plus the equal mark, and your calculator is reset.
okay.
Now try 2 by 3.
Okay.
Getting a lot of decimals.
Yeah, I'm like 6, 6, 6, 6, 6, 6, 6.
First, it was actually set to one decimal place. So calculator rounds off the answers to one decimal place.
Oh, okay. Now I'll try.
Yeah,
Now it should be correct, right? Instead
yeah,
of
that's
36.
also correct. Like that is also correct. That's one way. But definitely we would have different questions requiring different accuracies. So we'll round them off manually.
Okay.
B part. Can you find the value of PQR?
It should, so P should be 8. 40 should be 12.
P should be P should be what?
Oh, no. It should be 12.
That's
And
12,
then Q should be 24.
24,
And then it should be 35.
35. And then it says draw and find median. Do you have graph papers available with you?
Yeah, I am using graph paper like as an extra sketch paper right now.
Okay. Okay. In the next class, we'll be discussing medians, which I just gave a rough idea. And then it would be complete.
Okay.
So I think I'll just share these two questions with you so you could have a practice drawing two cumulative curves.
Okay.
Would be enough. And then, yeah, maybe we'll complete this tomorrow in half of the class. 90% is already covered. And then we can also touch a new topic with that. And
Okay.
do ask your father about the test.
Yeah.
That's not very lengthy. Those are first four topics only. Fertile. So what is this? This is basically whatever the values are of the total. This is 50% of total. This is 25% of total. And this is 75% of total. As we can see in this graph, there's 64 written. So 50% of that would be 32. 25% of that would be 16, and 75% of that would be 48. There are different ways to write it. We can write 1 by 2, we can write 1 by 4, we can write 3 by 4. 3 by 4 of total, 1 by 2 of total, 1 by 4 of total, and so on, as it is written in this graph. 1 by 4, 3 by 4, and half. So whenever they ask you about lower quartiles, that is straight away 25% from the y-axis, and then x is the actual answer. 75% from the y, and then that is the actual answer and median. Having said that, this brings you to interquartile range. Interquartile range. That is upper quartile minus lower quartile. Also written by IQR, interquartile range equals upper quartile minus lower quartile. And let's give one more name to it. This is also asked, written, or represented by Q1, Q2, and Q3. Like lower quartile is Q1, median quartile is Q2, and upper quartile is Q3. So when we talk about interquartile range, that is upper quartile minus lower quartile. So upper quartile minus lower quartile, we knew that this was at 25%, this was at 75%. So may I say this is representing the 50% data in the mid. So this is the interquartile range for this particular question. That is
So
15 minus
since
11, 4.
the upper quartile minus the lower quartile will give us the middle range.
Middle range, middle 50% range.
Okay.
Now forget what this graph is about, which is actually about the marks. Let me say these are masses of potatoes. I have 64 potatoes, and these are masses of potatoes in grams. So I would say that the potatoes range from 7 to 18 and 18 grams in mass. And I can say 50% of the potatoes lies within 11 to 15 grams. Would you agree?
50% lies in 11 to 15.
Yeah. Lower quartile is at 25%, that is 11. Upper
Yes.
quartile is at 15,
So yeah,
75%.
in between.
So
Yeah.
50% of the potatoes lies between 11 and 50 at the median, and the interquartile range is 4. Now, if this range would be smallest possible, that would actually mean that most of the potatoes are of same mass. That actually means a lesser spread. Does it make sense? If we
So
just
the
bring this,
lowest. Yeah.
if we just bring this example back to marks, keep your class in your mind, and I say the interquartile range is 2. That actually means that 50% of the students range between those two marks, whatever that may be. So that would actually show that most of the students are close to each other in marking. Now, if My upper quartile and lower quartile, let's say out of 25 marks, the upper quartile is says 20 and lower quartile says 18. So my interquartile range would be 2. That means 50% of the students are close to each other in markings. And when I know that the lower quartile is 18, that is a very good result compared to something that if the lower quartile is like 7 marks and the upper quartile is like 9 marks, this is still 2. All of the classes close to each other, but 50% are already failing out of 25. So what is interquartile range? That is a measure that most of the data is close or further away from each other. If that's close, we can make decisions on it. That means we are getting a good response. Let's say
But
we
like,
are
wouldn't the out of a total, wouldn't the like the numbers spaced out? Wouldn't that always be the same like distance anyways?
that would depend. What are we talking about? Let's say we are talking about tennis balls, long tennis at school, and we measure their masses in the standard mass of the ball is fixed in grams. And if the interquartile range is large, that would mean some balls are heavy and some are light. Large interquartile range would mean that is not acceptable. And if we have lesser interquartile range, that means balls are close to each other in masses. Okay, just keep your class in your mind. If I talk about the body weight of students, I don't know about your class, but just tell me if you would plot their masses, will you have a small interquartile range or large?
I think it's small.
Small. Now, when you said small, I would assume that most of the students are way close to each other.
Yep.
So, getting my point, I didn't know the actual data. You just told me interquartile range, and I assumed that most of them weigh around each other, but I never know that every one of them weigh around 115 kgs, or they weigh around 60 kgs, or they weigh around 48 kgs. That would be my next question. Maybe I'll ask you the lower quartile or the upper quartile or something else for more information. But
So the
in
higher a number is, that means like there's gonna be more space between the
yes,
interquartile range.
yes,
Okay.
because this is actually the difference between upper and lower, 75% and 50%. For example, we talk about, have you tried fries from McDonald's?
Yep.
So whenever I tried, I just feel that it's always the same. Most of the time, same size, same taste, same everything. So I would assume that they are using potatoes which are mostly close to each other in size. So at McDonald's, the weight of the potatoes would have a small interquartile range than compared to the ones we use at home.
Okay. But
Yeah, go on.
so there has to be like a lot of a difference between them. So the smaller number and the larger number. That's how there's a higher interquartile range,
Yes.
and
Just, just
the smaller
suppose
it is. Yep.
just suppose we are talking about table tennis ball. Now, if you have 100 of them, I think every one of them would be within the range of 1 gram. If you have 1,000 of them, still they'll be within a range of 1 gram because that's how they're made, the standard. So interquartile range would be very less, would show you that the ball or the manufacturer has a good standard, a lesser standard deviation, and he is making them precise. If
Okay.
you just order homemade cupcakes and they're all of equal size, so the interquartile range would be small.
Okay, I see. So the smaller it is, the more closer the values are together.
Yes.
Okay.
If we are measuring athletes, They are running in the ground, and we have a lesser interquartile range that would show that most of the athletes cross the finish line close to each other. Larger interquartile range would mean some are very good, some are fast, and some were slow,
Okay.
because IQR is actually representing 50% of the data. That too at the middle. Not very high, not very low, at the middle. Let's look at this worked example. The percentage scored by 1,000 students on an exam is shown in this cumulative frequency curve. Use the cumulative frequency curve to find the estimate for a median score. Now, where do I strike a line for median score?
500.
500.
500.
It is exactly between these two. Let me change this color. So between these two, it strikes right here. And I think this is two box each 29. Or maybe it strikes a little ahead. Let's make it 30. Second says, now even before we calculate the upper and lower quartiles, what do you think the spread would be, less or more in this case?
I think it would be more.
Very nice. And if the graph just looks like this, then the spread would be
Less.
less.
The steeper it is, the more it basically there's this the closer the interquartile range is.
Yes.
Okay.
So it says now lower and upper quartile. So lower quartile, 25% of 1,000 is 250. This is 200. This is 300. Somewhere here is 250. And I'm taking 11 for this. And upper quartile would be 750, 600, 800, mid is 7, and 750 somewhere around here makes it 90. So interquartile range is 90 minus 11, 79. You see? Now these were scores of 1,000 students, and 50% of them lie between 79. That's too large. Many of them are failing. They're not close to each other, and the interquartile range shows that. Any doubts?
No.
Now, there's one more thing. If we just compare two classes at school who has IQR lesser, that means all of them are scoring close to each other. That may be high, that may be low, but one thing for sure, they're scoring close to each other. So teacher may have same strategy for all students. But in this particular class, we can see that some are at a very low score, some are at a very high score. Maybe the teacher needs to prepare two different worksheets, or maybe three, containing levels basic, intermediate, and uh, uh, advanced levels.
So that's why people might do like a mock test
Yes.
before an exam. Okay.
In the real world, actually, the mock is just to make the student realize where they stand,
Yeah.
and they need to, which areas they need to focus on.
Okay.
Okay. So let's see what we have next. This is just the solution of the previous question. Percentiles. Now, in the exact same manner as we did, just a quick revision. What percent was Q1?
Q1 is 25%, Q2 is 50%, and Q3 is 75%.
Very good. Just to not ever get confused, answer is always on x-axis. Sometimes students just get mistaken. If this is 80, median is 40, this is 20, this is 60. In answer space, they would write 20, 40, and 60, and interquartile range as 60 minus 20. This is not the answer. Answer is always on the x-axis for the quartiles and interquartile range.
And it
Now,
always
just
has to be on a cumulative frequency graph, right?
yes.
Okay.
Now, after saying that, percentiles, this could be anything. They could ask 12th percentile, they could ask 84th percentile, 76th percentile. So whatever it is, of the total, let's say they're asking 12th percentile. So I would do 12 over 100 of 80. 12 divided by 100 of 80 is 9.6. So 9.6. Now I'll go at 9.6 and read the 12th percentile. That's it. Nothing more to it.
Okay.
Where this could be used is like someone would say that one who crosses the 60th percentile passes the exam. One who is crossing after the 17th percentile of a race does not qualify, because in race lesser values qualify, in exams higher values qualify. One worked example, the cumulative frequency curve shows the test results of 200 candidates who have applied for a post rank kidlers. Only those who scored above 80 percentile will be called for an interview. Now 200 is total. 80th percentile of this is 160. So we go at 160, we read the mark, and this is 35 marks. So who scored more than 35 or 35 would be called. So this is what percentile is for. Practice exercise. The length of 32 metal rods were measured and recorded on the cumulative frequency curve. Use the graph to find the estimate for median, Q1, 2, interquartile, and 40th. So let's do median first. Give it a try. Median.
I know it's the 50%, and that would be 17.5. So I just have to go from there.
Yeah, 50%. Median is 50% on y-axis, and from there we draw the horizontal line and read what is on the x-axis.
30.5.
30.5. And what
Yes,
was the median on y-axis? Mid
I
value
got
on y-axis.
17.5.
Uh, there you used 35, right?
Oh wait, sorry.
Yeah, that's a mistake. So what would you use?
Sorry.
What would you use on y-axis? Half of what? Always the total. And the total is where the graph ends.
So that would be at, yeah, 32.
Yes. So Q2 for 32 by 2 is 16. So we read it. Let me just zoom in it. Is just rotating our eyes. So these are after the two boxes, that's 16, and it hits at this point, which is 30. So my median is Q, no, 30. Then Q1, 1 by 4 of 32 or 25% of 32
8.
is 8. 8 is again every two boxes 1, 5, 6, 7, 8.
So it has to be 27.5.
27.5. And what would be Q3 against? 3 by 4 of total?
That would be 24.
24. So this is 24. That would be actually very easy in paper and pencil when we can use a scale. So what would this value read?
33.
33. And interquartile ranges upper quartile minus lower quartile is
5.5.
5.5. And the 40th percentile, no, 40th percentile is 40th of
12.8 on the x-axis,
on the y-axis.
and yep, sorry, y-axis, and then
So this is 10, that's 11, that's 12, that's 13. So a little before that, let's say it strikes a little before this line. So two boxes each for 1 point, 26, 27, 28, 29, 29.5, I guess. So that's it, reading the graphs. The cumulative frequency curve, whatever it is, before reading that, what do you think? Paper 1 was easy or paper 2?
I think paper 1 was easier because it's more steep.
And if I say 50% means 60, and 50% of the students on paper 1 are getting these much marks, while on paper 2 are scoring this much.
So paper 2 was easier.
Paper 2 is easier. You see this line? This is actually towards right hand side. It is towards more marks. So in this case, paper 2 was easy because the shift is towards right hand side, which is more marks. The cumulative frequency curve compares the result of 120 students obtained on two math papers. For each paper, use the graph to find the median mark. Median and then interquartile. So median at 60. This is one box before that. 48. 48 for paper 1. And exact intersection is 60 for paper 2. Interquartile range. Paper 1, paper 2, upper quartile minus lower quartile, upper quartile minus lower quartile. So I'm going for lower quartile first. There were 120 and 1 by 4 of 120 is 30. So this is 30 and the other one is 44, right?
Yes.
30 and 44. Uh, do it for the upper quartile.
It has to be 90.
90. One box before that,
So 58.
58 for the first one,
And
and
for the second one, 72.
72. So 28 and 72 minus 44 is 28. Surprisingly same. The 60th percentile for both of them. So 72 and it's
52.
52, and the other one, I think that's the third box,
66.
66. What mark would you need to get to be above 90th percentile on each paper?
Well, it's 108 on the y-axis.
What mark would you need to be above 90th percentile? Yes, 90 by 100 of 120, 108.
Yep, 108.
So 108 is one box before that. This is two boxes before the center line and one box before this line. So two boxes before that.
66. First paper.
Two boxes, yeah, 66. And one box before that is
78.
78. So we need to score 66 on first paper and 78 on the second paper to be on the 90th percentile. Total score is 100 for both. This cumulative frequency curve shows the masses of 500 12-year-old girls in kgs. I think this would just resemble that example we discussed, masses of students at school. Use the graph to work out the median mass of 12-year-old girls. Median mass.
45.
That is 45. How many girls have mass between 40 kg and 50 kg?
So it's 100 to 430. But how many guys in math between? So
That's
you will add those values?
right. No, you subtract those values
Okay.
because before this 100, they are lesser than 40 kg. After this 430, they are more than 50 kg. So we are talking about these students. So
So
this is
330.
430 minus 100 is 330. What percent of girls are unable to go on an amusement park children's ride if the upper mass limit is 51?
$60?
See, the upper mass limit is 51.
No, are
So,
you saying no, can you go back to the question? Is that saying how many girls can't go on it?
yeah,
What percentage of girls?
yes.
Okay.
So, first we select this 51 and it hits like here in the middle. So,
Isn't
this is
that
what
52?
I'll just erase it and zoom in. I think that's the midpoint. You see, this is 51 mark, and this is actually in between those five boxes. So if it is in between these two, that needs to be 450. Do you read this point more than half?
The 51? It's more than the 50% mark.
Okay, in that case, we can read it more. So one box is actually 20. Wait, let me zoom in even more. This point right here, and this is the full box.
Okay.
So you're saying this exact midpoint is 450. So you're saying it's above that.
No, I'm saying that the place where you put the 51, I think that's 52 for the x-axis.
What? No, no, these are one box each. 51, 52, 53, 54, 55. That's one each.
Okay.
So at 51, when we come here and read this box, this is on y-axis, this is 450.
Okay. Wait.
So,
Yeah, it's 450. Okay.
so 450 would mean these girls are not going on that right. So from 450 to 500, these are 50. 50 out of 500 times 100, 10% of the children are not going on that right.
So 50 girls is 10% of the 500.
Yes.
Okay.
This cumulative frequency table gives the speed of 200 cars traveling on highway from Kuala Lumpur airport into the city. Less than 60 are 2, 60 to 78, and so on. Draw a cumulative frequency curve to show the data. So cumulative frequency is already given. Drawing the curve, I'm just making a sketch, a random sketch. On x-axis, we would use 60, and then 70 upper values will be used. So at 60, it is 2. and the highest value on x-axis is 140, and the highest value on y-axis is 200. This is 0, and this is 2. And the scale is given. That would be helpful when we are using graph paper. B part says use your curve to estimate the median, Q1 and Q3. So against 100, we'll have our median. Against 50, we'll have our Q1. Against 150, we'll have our Q3. And interquartile range Q3 minus Q1. The speed limit on the stretch of the road is 120 kilometers per hour. What percent of cars were speeding? So speed limit is 120. So we find 120 on x-axis. Let's say this is 120. And we go and find these number of cars were overspeeding. Any doubt in understanding the question?
No. It's just the 120 and above.
Sorry?
No, nothing. It's just the 120 and above.
Yes.
Okay.
Okay. I'll open up some more practice questions. Give me a second. Can you see this?
Yes, I can.
Okay, let's do some cumulative frequency questions. 80 cyclists were asked the distance in kilometers they cycled last week. So 80 on y-axis and the distance they cycle is on x-axis. The cumulative frequency diagram represents the results. Use the graph to estimate the number of cyclists who cycle between 60 and 80 kilometers. So between 60 and 80 kilometers. 32 and between 80, 62. So there were 30 cyclists who cycled between these two given distances. B part says find the median distance cycled. Try this.
$66.
That's right. The interquartile range for the distance cycled. Let's write it here and then you'll use it later. Upper quartile and lower quartile.
So upper quartile would be 78.
Correct.
And 48 would be lower quartile.
Correct. So we're using these two, 78 and 48. So interquartile range is 30. A group of 80 students took a physics test. This table shows the distribution of their marks. Complete the cumulative frequency table. So how many are less than 10? How many are less than 20?
16,
Correct. Less than 30?
30,
Less than 40?
52,
Less than 50?
70,
And less than 60?
80.
80. And this 80 and this 80 confirms that no mistake was made. Draw the cumulative frequency curve for this information. So upper ends are already given 10, 20, 30, 40. So against 10, we are at 4. At 20, we are at 16. At 30, it is 30. At 40, it is 52. At 50, this is 70. And at 60, it is 80. And at 0, it would be 0. Do this practice to be able to make a smooth curve. Here, this is not smooth. In exam, this should not be the case. The pass marks for the test is 45. Use your cumulative frequency curve to estimate the number of students who passed. Pass marks are 45. How many students passed according to this graph? I would just like to give one more try. It's still bad. Okay, at 45 marks, how many students do you think have passed?
16,
60 students are passing at 45 marks. Even if you think that's 60, I think that's 61.
yeah.
But
So no,
are these students passing
no, they're not passing, so it's just above that. So
above that?
80 minus 61.
Yep. 80 minus 61. 19 students are passing.
Yep, 19.
Now we have some mix of questions. Jamil recorded the number of text messages sent by students in his class on one day. The results are shown in the bar chart. Frequency is given, number of text messages given, the bar chart to find the number of students in Jamil's class. Right.
Thirty-one.
Correct. This was 3, 4, 8, 7, 6, and 3. B part says the median number of text messages.
Six.
So median 15, 3 plus 4 is 7 plus 8 is 15, 6. That's right. Model number of text messages sent.
5.
Very good. Pie chart. In a survey, some people were asked which of the three songs labeled A, B, C they liked best. The diagram shows part of a pie chart illustrating the results. The angle of the sector that represents the people who liked C is 168. Complete the pie chart.
So we just have to draw a degree of 168.
Yeah, degree of 168,
see.
that needs to be drawn using that protector.
Yep.
So I just place the protector somewhere, and basically it would be actually larger in size than this diagram. So I'll see where 168 ends, and I'll just mark a dot outside it. Once done, I'm going to remove this, place my ruler, and draw that line. So this is 168, and it would be a bit more than that. So this is 168. Complete the pie chart. 168 done. So 360 minus 168 minus 45. This is 147. B part says expressing your answer in its lowest term, find the fraction of people in the survey who liked C. Fraction of people who liked C.
That's basically just 168 over 360.
Correct. So 168 over 360 is 7 by 15. Given that 30 people liked A best, calculate the number of people in the survey.
So 45 over 360 times 100 is the percent that equals to 30. $240.
Correct. You're using percentage. I would just suggest use unitary method that says this is A and this is total. 45 degrees and 360 degrees. A is 30 people, so that would be X. So when we just cross multiply, this is 360 into 30 by 45, and you get 240. Like percentage is correct, but first you would have calculated percentage and then again people.
So 45 to 360, 30 to the total.
Yeah.
Okay.
45 to 30 and 360 to X.
Yep.
Frequency density. The distribution of length of time taken by an engineer to repair some washing machine is given in the table. The histogram represents some of this information. Find K.
So K would be 1. No.
No,
No, it would be 2.
no.
No.
Keep increasing, there'll be K.
Because it's the midpoint over the frequency? Or is it the frequency over the midpoint?
Frequency density equals what?
Frequency over class width.
Frequency over class width. Now, if I may say, this is 1, 2, 3, this is 1, 2, 3, frequency density is 2. So 2 is equals to frequency is K and class width is 2. So K equals 4. Complete the histogram. So we're plotting frequency densities. I'll write class width here. First two are already done. This is 1, this is 3. And frequency density is frequency divided by class width. Frequency divided by class width. So from 4 to 5, we have height of 4. From 5 to 8,
So it is
height
3.
of in exam you do this as well, this shading, because here we are using different colors. That is pretty much visible. In exam, that would be a lead pencil over black printing. A group of 100 students were asked how many minutes each spent talking on their mobile phone during one day. The histogram summarizes this information. Use the histogram to find the number of students who spend between 0 to 10 minutes.
$15.
Say that again.
15?
0 to 10 minutes. This is 0 to 10.
Yes.
Frequency density is equal to frequency divided by class width. So frequency density is 1.6. Frequency is unknown. Class width is 10. So there are 16 students.
Sorry, I think I read it as 1.5. That's
That's
why.
1.6. Those are 1, 2, 3, 4. My mistake. That's 1.5. 15.
It's cumulative class width times the frequency density.
Yeah, no, that's right. I just misread that as 6 boxes. This is 1, 2, 3, 4, 5. You're right.
Okay.
Estimate the number of students who spend time between 25 and 65. See one more thing. Even if we use the formula or we just find the area, area is also giving us the frequency, because frequency density is equal to frequency over class width. We're just multiplying the base and height. Base is the class width and height is frequency density. So you can just look over the area and answer the second part. It starts from 25 and ends at 65. So this is where 25 is. So 25 to 65. Try this.
One 26.
How many are you getting?
126.
126. I'm getting only 27.
Okay. So I just basically did the 25, like 60 minus the 25, which,
60 minus 25, which is 35.
yeah, 35. And then I times that 35 with the height, which was 0.6.
Yes, then I did.
And then I did the 5 times the 1.2.
Yeah.
And that was,
And then that was 27.
okay, I'll try again.
Some of the students they ask, is showing the working important? This is why. If the working steps are good, he'll rate 1 out of 2 if the final answer is incorrect.
27, yes.
A pie chart is drawn to represent the information shown in the diagram. Calculate the angle of sector that represents the students who spend between 0 to 10 minutes talking on their mobile phone. What would be the angle? You might need to consider the full question.
Fifty-four.
Correct. Did you just calculate all of those students? Because they were 15
No,
out of.
I just did 15 out of 100 times 316.
That's good. There's totals given in the question. Okay, frequency polygon. The table summarizes the time in minutes taken by a group of people to complete the puzzle. On the grid next page, draw a frequency polygon to present this information. Write down the model class. Okay, first of all, let's draw the polygon. In polygon, what do? We use the midpoints. This is 2, 6, 10, 14, and 18. We use the midpoints and the height. So 4 and the midpoints. And y-axis is empty, so we need to choose a scale. The highest point is 8. So if I just mark these 1, 2, 3, 4, 5, 6, 7, 8, it is not going to cover my graph. It should be more than 60%. So I'm taking two boxes as 1. So taking this as 4. This is 1, 2, 3, 4, 5, 6, 7, and 8. So this is 487, 4, 8, 7, then 4, 2. 4 and 2. Now the frequency polygon is you. This is not freehand. Use ruler and draw straight lines joining these. This is first, second, third, fourth, fifth, and sixth line. This is frequency polygon. Write down the model class. Which one is the model class?
4 to 8. 4 to 8.
Correct. 4 less than t is less than equal to 8. How many people took more than 8 minutes to complete the puzzle?
13.
Correct. Imran says the longest time to complete the puzzle was 20 minutes. Explain why he may not be correct.
Because that's only for a group of people, not
Yeah, because we're not
not a
sure.
majority. Yeah.
No, we're not sure that these two people how long they took. Like it could have been 17, it could have been
Oh, I
19.
see.
That's why he may not be correct. The length of leaves of a plant were measured. The results are shown in the table. Length classes are given, frequency is given, frequency density. What would be the first value?
That would be 4.
Correct.
And then it would be 5.
5,
And then 6.
6,
6.
6,
4.
4. Complete the table to show frequency density is done. One leaf is chosen at random. Find an estimate of the probability that the leaf is more than 6 centimeters long.
So more than 6 centimeters long would be in the 5 to 7 section, right?
Right?
To the 7 to 10. So it would
Yeah.
be 24 out of
Now, this time, this is 6, more than 6. Now just consider if we draw frequency density. So this is going to be 4 from 1 to 3, then 5 from 3 to 4, then 6, and then 6 again, and then at 4. So when we are looking at these values, this is 1, 3, 4, 5, 7, and 10. Remember, we just took the area from 25 to 60 for the last graph.
yes.
So this was actually showing 12 people. So no need to actually draw the graph because this is 12 and these are equal to divisions. So half would be on this side, half students will be on, half leaves will be on this side. So this 6 and 12, which are
So
more than 6
18.
18
So
out of
18 out of total of 33.
I think I was getting 43, 8 plus 5 plus 6 plus 12 plus 12. I'm getting 43. You have to add this column, this row. Are you getting 43?
Yeah, 43. And then do we have to turn that into like a percentage?
No, probability is just the fraction. 18 out of 40.
Okay.
Now, this is just a reading question, like the one we practiced in book. The time taken by each of 120 runners to react to the starting gun were recorded. The cumulative frequency curve summarizes the results. Find the upper quartile.
That would be 90.
Hmm, So what is this reading? This is the seventh box after one.
Yes, it's the seventh box, but halfway through it's 1.5. So 1 point,
This is actually less than 1.5.
yeah. So 1.47.
This is 1.35. See, these are 20 boxes.
Yep.
So 1 divided by 20 is value of one box. That is 0.05. And we have 7 boxes after 1. So this is 1 plus 7 into 0.05, which gives you 1 plus 0.35.
1.35. Okay.
B part. Find the 40th percentile.
48.
48. Now, where is it going to be? One small box on this side measures 2. So 40 and 48 is going to be 4
Just
boxes. 1, 2, 3, 4 boxes. This is second box after 1.
So that'll be 1 plus 2 times 0.05. So that would
Okay.
just be 1 plus 0.1. So yeah, 1.1.
Find the number of students who took less than 1.5 seconds.
Hundred and two, right?
These
The
are 2
blue
boxes.
one. Yeah.
So this is 104. One small box measured 2.
2. Okay. And then we have to subtract it from the.
No. Number of students who took less than 1.5 are 104. These are who took more than 1.5.
Oh, so it's just up to that point. Okay, so it is just your 104.
Yes.
Okay.
Okay, I'll share this sheet with you along with the solutions. I think I've shared this type of sheet before also for different topics. And you can practice few questions in your free time. Is the test done yet?
Test is not done yet. I had to like write other stuff that's yesterday for school.
No issues, no issues. I just wanted to say that do that on priority. After that, you can
Okay.
practice the questions.